So now let's take a look at a few exponential equations and discuss how we can solve these different types of equations using some of our properties in order to deal with it. Well, this first one right here, I know it says base e, and a lot of people don't like base e for whatever reason, but really this is an example of using our property, our one-to-one property, right, that said if a to the x is equal to a to the y, then it must be that x is equal to y, right? And so let's use that property right now. In this first case, e to the 2x equals e to the x squared minus 8 obviously must imply then that the exponent 2x by our property at the right must equal x squared minus 8. And the rest of this becomes a nice algebra problem here where we have a quadratic, right? Let's subtract 2x from both sides and rewrite our equation so that 0 is equal to x squared minus 2x minus 8. And to solve this kind of equation, you'll recall what you would do is to factor. And let's factor this one. Now we could actually use a couple of different methods, but we're going to factor because this is easiest right here. This is the kind of polynomial that has x as the first term in each binomial, right? Because x times x gives us x squared. And we would need to find two factors of negative 8 whose sum is negative 2. Well, the answer to that is negative 4 and positive 2. Because when we multiply negative 4 times positive 2, we get negative 8. And if we look at our middle terms, negative 4 gets multiplied by x to give us negative 4x. Positive 2 gets multiplied by x to give us plus 2x. And negative 4x plus 2x is negative 2x. Now, when these pair of factors are set equal to 0, we set each factor equal to 0 and solve. And we find that in the first case, x would equal 4 has to be one of our solutions. And in the second case, when we take x plus 2 and set it equal to 0, well, we find that x equals negative 2 is another one of our solutions. So we actually have two solutions. By the way, we should be able to check these, right? Like all good equations, we can always check by going through and just seeing what happens when we substitute into the original equation, and it should work out. Well, does it check out here? Sure. At x equals 4, if we substitute in e to the x equals 4, right? 2e to the 2x would be the same thing as e to the 8th. And of course, e to the x squared minus 8 would be the same thing as saying 4 squared minus 8. And, well, yeah, those two are definitely equal to each other because whatever e to the 8th is, it sure is equal to 16 e to the 16 minus 8, which is also 8. Same deal if we tried it with x equals 2, e to the 2 times 2 times negative 2 is negative 4, pardon me. And of course, on the other side of the equation, we're going to take e to the x squared, well, negative 2 squared is 4, minus 8. And sure enough, we see that e to the negative 4 is certainly equal to e to the 4 minus 8 because 4 minus 8 is also negative 4. So we've done pretty good. How about this next one right here? We've got 2 to the 3x, 3 minus x, pardon me, equals 565. Well, this is certainly not one of these properties on the left because 565 is not a number that is a power of 2. So what do? Well, this is a job for our inverse property, right? The one that said if we take the logarithm base a of a to the x, we get x. So what we're going to do is we're going to take advantage of this property and rewrite our expression here. And we're going to find that if we take the logarithm base 2 of 2 to the quantity 3 minus x, it will be the same as if we take the logarithm with a base 2 of the quantity 565 on the right. Now, in the first case right over here on the left-hand side, this is our property, the logarithm base a of a to the x. In this case, it's the logarithm base 2 of 2 to the whatever the exponent is in this case. So in this case, the logarithm base 2 and the base 2 with the exponent undo each other and leave us with 3 minus x. as being the number that is equal to the logarithm base 2 of 565. So now the next question right here, we need to isolate x. Well, now it's just a little bit of algebra. We could add negative 3 to both sides of the equation to get our x term by itself. That's going to give us negative x is equal to negative 3 plus the logarithm base 2 of 565. But to get x by itself, we need to multiply both sides by negative 1, and we would find that x is equal to 3 minus the logarithm base 2 of 565. Now, if we're interested in getting the decimal answer, which is what we usually end up doing in real applications, we would have to rewrite this expression one more time. So I'm going to rewrite it as 3 minus, by the change of base theorem, I'll call it the natural log of the argument 565 divided by the natural logarithm of 2. And that would be our exact value answer, which is exactly what we need.